supply chain. So the latest AFCOM State of the Data Center report indicated around 66% of respondents had a challenge or some kind of a situation with their supply chain, of whom 15% experienced some type of an outage. I always try and preach, you need to work with partners that can support obviously the delivery of the equipment, but then also what happens next, right? The infrastructure, the parts and componentry, the repair of it, which actually kind of brings us to a really important point around uptime, resiliency, and structural integrity for these kinds of systems. We don't need to get into the fact that these are mission critical. We know they are, right? They run some of the most important government, local utilities,
absolutely,
everything else in between, right? As opposed to in the past where you could just get out a piece of paper and a pen and take notes for a couple hours. It's just not going to happen anymore. So these are supporting, impacting communities, financial institutions, hospitals, police stations, literally everything in between. What are some design and operational principles, especially in today, that you've seen go into the market that help reduce that risk and really emphasize that critical nature of critical infrastructure?
Reliability is who we are. It's our lives. In fact, you make a good point. You can't afford to have these power outages because bad things happen not only in the data center but just in the infrastructure of the United States. And people tend to lose their sense of humor when they lose their power. Yeah, I know that for sure.
Or the internet, but yeah.
Yeah, or the internet. Yeah. So, as far as from an automation perspective, I believe we have great technology. I really do. Well, we invented it together, right? So people like our technology. But there's two things I think they like better. They like the reliability, 3 nines, 4 nines, 5 nines. And from day one, we do have the advantage of serving power and water, but most of our sales are in power. So we got that from the very, very beginning. And the way we designed Ovation was, it's fully fault tolerant, completely redundant. There's a state machine that fails over. From bottom to top, it is extremely reliable. And we have about 40 million lines of code. Why it's so reliable, it's very mature code. Computer science and software is all about code coverage. The longer you use it, right, and the more people that use it, and the broad 2 million megawatts around the world, you tend to find out all the bugs,
Yeah.
And it's very, very, very reliable.
Users are great at finding bugs.
Yeah, so back in the 90s, we probably had, but now it's a very, very reliable, very stable, incredibly reliable system. And I think that's why the first thing is why people work with us. The second thing is our people. Yeah. We have so many people that understand not just the automation and the technology, but the power plant itself. The questions we normally get when a customer calls us, it's not about the Ovation control system, it's about the power plant process. I'm having this issue with my steam turbine. Yeah. Can you help me? Yeah, Ovation's working fine. That's not what they need help with. It's not like my mouse isn't working or something like that. It's like I need help with a steam turbine, or I need help with my whole combined cycle plant or a coal plant, and that's the kind of expertise that we bring to our customers.
It's very helpful to note that. Let's talk about your customers. So this year at Data Center World, we had close to 7,000 people attending. We had about 1 million pounds of gear on the expo floor. It's currently in the industry the largest, most expansive expo floor for our industry that you could walk, touch, feel this stuff. And someone was brave enough to bring in a full-blown transformer. I tried to take a selfie with it. I kept having to back up because I couldn't get this whole thing into the picture.
Okay.
So putting your data center cap on, right now I need you to speak to the data center audience because they are going, I don't want to say an existential situation, but a little bit in terms of understanding what power concerns are, community relationships and so on, but this is specifically around power. Emerson has grown up and has done extraordinary work, like you said, in terms of inventing systems, solutions, whether through computer science or just sheer innovation around power and utility. I'm really curious, what can a data center industry learn? And this is you speaking directly to those operators, not just the hyperscalers either, but the ones building traditional data centers as well. What can they learn from the utility around reliability, safety, and that long-term asset management perspective, because it's also fresh and new to them. How do they take it all in?
Well, let me start with, why are people doing this?
Yeah.
Why are people building data centers? Why is the whole, especially in the United States, around the world, why? Well, I can tell you from our perspective in power plant, I'll go back to the control room that I was talking about earlier. What we're creating with, and I think the utilities see this, and the hyperscalers, maybe not so much, but I'll tell you what we think they're seeing. We are creating the smartest person ever to walk into that control room. No offense to the people that already work there, right? But the smartest person ever to walk into that control room, right? So it's the Gen AI that you can run it in the cloud, which is why, but typically you can have a large language model that can run locally on the system. This is the whole Gen AI concept. And you can train the LLM to know everything about that power plant.
Mm-hmm.
In an 800 megawatt combined cycle, there's probably 5,000 sheets of logic. And I'll show you one after this talk.
Yes, please.
Here, okay, I'll just show you one sheet. Analog and digital logic. It's very complex. Now imagine 5,000 sheets. No one person can possibly ever, even the people that design it, have a problem. 5,000 sheets of logic, train the LLM. All the turbine documentation, all the HRSG doc, if it's a combined cycle. Valves, transmitters, pumps, historical data. So you're creating this person, basically, that can interact in two ways, right? As a virtual assistant, where you can ask it questions and say, I went to training, but it was only a 3-week class and I kind of forgot everything, which is really what happens.
Right.
So you have this tremendous in-depth knowledge of the automation itself. But it's better than that. There's an agent builder that's part of this system that you can build agents, and it can monitor. There's an event detector, and it can monitor. This is the LLM doing this, and the agents to detect anomalies that may happen. So, for example, a combined cycle. Every combined cycle has integrated startup procedures. You sit in front of the console. You're trying to be the client online, but the operators still manage to trip the unit because they're a human, right? Or they don't know exactly what they're supposed to do, and next thing you know, they tripped. And I know a lot of power plant managers around the world, and most of the ones I know don't have a sense of humor to begin with, right? So if you trip the unit when you're trying to bring it online, it doesn't usually end well. But now, if you think about this integrated LLM in real time to the millisecond, I'm not talking about IT up here, I'm talking about integrated AI to the millisecond. As the operators bring up the unit with these integrated startup procedures, it can sense ice sensor in startup. Did you know the feed water block valve was closed? Do you see the level that are you monitoring all that? Oh, no, I didn't see that, right? Open the feed water block valve, right? And you can continue on. If they didn't notice that, for example, it would trip the unit. Wow. I call those $1 million saves or $10 million saves. If you're bid into the market or you have a power purchase agreement and you're trying to get the plant online, it's extremely important. So that's the why it's being done in a power plant. And that's how we're changing. I mentioned we're changing the world and economies all around the world, but that's how we're changing the way power plants will be operated forever.
Mm-hmm.
That's my message to the data.
No, it's a very brave message. I'm hearing, we're a 130-year-old company and we're embracing the concepts of AI and Gen AI to improve our systems. But what I don't hear you saying is it's not replacing people. I believe that as well. Human in the loop. It's everything that we've developed has been human in the loop.
Mm-hmm.